Welcome to This Explainer. Today, we're exploring a technology that is quite literally lighting up our world, using nothing but the free rays of the sun. You see them everywhere nowadays, perched on neighborhood rooftops, stretching across vast open fields, maybe even lined up along the highways. But understanding the actual magic that happens inside those sleek panels, well, that's a whole different story. Our goal today is to completely demystify solar energy. Okay, let's dive into this.
It's kind of like magic when you really stop and think about it. I mean, how exactly does a quiet, sunny afternoon outside translate into the heavy-duty power you need to run your air conditioner, spin your ceiling fans, and keep your television glowing inside? It's this massive abstract concept. We're literally harnessing the power of a star millions of miles away, but the result is incredibly grounded in our everyday household reality. We're going to connect those dots today.
To get there, here's our roadmap. We'll start with free electricity, move into photovoltaic science, look at panel types, talk about inverters and batteries, weigh the pros and cons, and finally help you make the final decision.
Section 1. Free electricity. Let's talk about getting power directly from the sun.
We all know solar panels capture sunlight, right? But let's transition from just looking at them as these shiny objects on a roof to understanding the incredible process happening right beneath that glass surface. The real secret to this technology comes down to a scientific term called the photovoltaic effect. Now, what's really interesting about this is how simple that intimidating word actually is when you break it apart. Photo simply means light, and voltaic means electricity. So we're quite literally talking about a light electricity effect. That is the core mechanism of every single solar panel you've ever seen.
Moving right along to Section 2, photovoltaic science. It's time for some atomic magic.
So how does that light electricity effect actually happen? Let's zoom way into the microscopic level to see how a very basic, seemingly ordinary piece of silicon pulls off this incredible trick. Most solar panels are made from silicon. Now, in its natural state, silicon is a semiconductor, meaning it's normally a pretty poor conductor of electricity, essentially an insulator. But under the right conditions, it can become a fantastic conductor. Inside a solar panel, engineers take two specially crafted layers of silicon and press them together. One layer is made to be electron-rich, that's known as N-type silicon. The other layer is engineered to be lacking in electrons called P-type silicon. When these two dramatically different layers meet, they create this permanent electric field right at their border. In the science world, this critical meeting point is called the p-n junction. Now, picture a tiny particle of sunlight, a photon, traveling all the way from the sun and just smashing into these silicon layers. When that photon hits, it transfers its energy and literally knocks an electron right out of its atomic orbit. Boom! Suddenly, you have a free floating electron. And because of that p-n junction's electric field we just talked about, these freed electrons are violently pushed in one specific direction. It's like a microscopic relay race. Millions of photons knocking millions of electrons out of orbit, all being driven in a single direction. And guess what? A flow of electrons moving in one direction is the literal definition of an electric current. That is electricity. But, here's the catch. One single, tiny solar cell doing this microscopic relay race, it only generates a minuscule amount of electricity. We're talking about half a volt. You couldn't even run a basic household appliance on 0.5 volts, let alone power a whole house, which sets up the absolute necessity of scale. And this brilliantly illustrates how engineers solve that exact problem. Since one cell gives us a tiny half volt, we just link a whole bunch of them together. We wire multiple cells into a single grid to create a solar panel. Then, to generate enough power for an entire house, we wire multiple panels together to create a massive solar array. By scaling up from the microscopic to the massive, we basically multiply that tiny half volt into the thousands of watts you need to actually run your air conditioner. Section 3, panel types. Mono versus poly. Let's pull the camera back even further now and look at the physical hardware options available to consumers today. Because as it turns out, not all of those panels we just scaled up are made exactly the same way. When you're looking to buy, you'll basically encounter two main types. First up, we have monocrystalline panels. Mono meaning single. These are cut from a single, highly pure silicon crystal. You can usually spot them right away by their sleek, dark black color. Because the silicon atoms align perfectly, electron flow is super easy, making them highly efficient. But as you might guess, that purity comes with a higher price tag. On the flip side, we have polycrystalline panels. These are made by melting multiple silicon crystals together and pouring them into a mold. They have a distinct light blue, almost shattered glass kind of look to them.
Because the crystals are mixed up, electrons have a slightly harder time flowing through the joints, making them a bit less efficient. They do take up more space on your roof to generate the same amount of power, but they are significantly cheaper to manufacture and buy. It's a classic trade-off.
Section 4, Inverters and Batteries. Let's talk about usable power and storage. Catching the sun is really only half the battle, because straight out of the panel, that electricity isn't quite ready for your TV. See, solar panels produce direct current, or DC electricity, but practically every appliance in your home runs on alternating current, or AC electricity. If you plug your TV directly into a solar panel, absolutely nothing's going to happen. Enter the inverter. The inverter is essentially the translator of your entire solar system. It takes the DC language spoken by the solar panels and translates it into the AC language that your house actually understands. And beyond just translating, modern inverters act as the brain of the whole setup, monitoring power levels and protecting your home's circuits from sudden electrical shocks.
But that naturally brings up the most obvious question. What happens when the sun goes down, right? If there are no photons hitting the silicon, there's no electricity being generated. Well, you have two main solutions for the night shift. First is an off-grid system. This uses large batteries to store all the extra electricity your panels generated during the sunny afternoon. When night falls, your house simply draws from those batteries. The second option is an on-grid system. Here, you don't use batteries at all. Instead, during the day, any extra power you make is actually pumped out of your house and into the government's power grid. A special net meter keeps a running tally of what you gave to the grid. Then, at night, you pull power back from the grid using the credits you earned during the day. It's a pretty clever accounting trick.
Section 5, Pros and Cons, Weighing the Facts. Okay, it's time to take off the science hat and put on our practical advisor hat. We need to objectively weigh the real-world advantages and disadvantages of investing in a solar system. Now, the advantages are undeniably massive. The most immediate benefit for most folks is a drastic reduction in monthly electricity bills. From an environmental standpoint, you're tapping into a 100% clean, renewable energy source that doesn't pollute and actively fights climate change. You also gain a tremendous amount of energy independence, shielding yourself from those crazy fluctuating utility rates. And perhaps most impressively, these systems are built to last. A quality solar panel has a lifespan of 25 years or more, with incredibly minimal maintenance. You just let them sit on the roof and do their thing.
But we absolutely have to look at the other side of the coin. The initial upfront cost to purchase and install a system can be high, though subsidies and financing do often help. You are also entirely weather dependent. A week of heavy clouds will severely impact your power generation. Furthermore, you need adequate unshaded roof space. If you live in a high-rise or a heavily wooded lot, this just might not work for you. Finally, while maintenance is low, you do need to occasionally clean the dust off the panels to ensure those photons can actually reach the silicon. So the crucial point here is weighing these physical and financial realities against those decades of free power.
Section 6, the final decision. Is it right for you? Let's bring all of these microscopic and macroscopic elements together to help you figure out if this is actually the right move for you. If you're contemplating this, just run through this quick checklist. First, look at your consumption. If your monthly electricity bills are already very high, a solar panel system will yield a fantastic return on investment. Second, assess your real estate. Do you actually have enough open, sunny roof space throughout the day? Third, consider your budget. Can you handle the initial upfront cost? And crucially, do some research into your local area to see if there are government subsidies, tax breaks, or easy installment plans available that dramatically lower that barrier to entry. If you can answer yes to these questions, solar is likely a phenomenal choice for your household. We've journeyed from atomic particles colliding inside silicon all the way to translating DC currents and finally balancing your household budget. It's a brilliant, lasting technology that not only puts money back in your pocket over time, but actively builds a cleaner, more sustainable future for everyone. So, looking at your own roof and your own energy needs, are you ready to take that step toward a sun-powered future? Thank you so much for joining me on this explainer today. Keep learning, keep asking questions, and I'll catch you in the next one.